So here's a simple problem based on carbon 13 NMR, and here you have a C13 spectrum or 13 carbon spectrum for an organic molecule, and you have to see which of these molecule best fits the given carbon 13 NMR. Okay, so if you look at it, you can first start off with a very simple approach, count the different kinds of carbons, for distinct number of carbons we have in the molecule. You don't even have to start to think about what kind of carbons they are or what kind of functional groups you have in this molecule that have carbon, right? You just have to count the number of carbons. So 1, 2, 3, 4. There are 4 different distinct carbons in this molecule. If you look at this, that is a distinct carbon which is same as this, therefore count only 1, okay, because the molecule is symmetric. Therefore that is 1, 2, 3, 4, 5. This has 5 distinct carbons, whereas here you have 4, okay. So this cannot be the right structure. Here 1, 2, 3, 4, 5, 6, 7, 8. All of these are distinct carbons. This is same as this, therefore you will not count this twice. You will count only one of those methyl groups in the isopropyl group. Okay, so therefore you have 8 here, you have 5 here, so this is not the right structure as well. 1, 2, 3, 4, 5, 6, 7, 8, 9, which is different from this, 10, 11, and 12. So all of them are distinct carbons, therefore this cannot be the right structure either. Here, if you look at this, 1 is same as that, 2, 3, 4, 5, okay, and then 6, which is same as this, and this. Therefore you have 6 distinct carbons, and therefore that cannot be the right structure either. And if you look at this, you have 1, 2, 3, and 4. You have 4 distinct carbons, which is what you have here, okay. And by the looks of this here also, you can see that these structures are also going to have more than 4 distinct carbons, therefore you can ignore them also. So let's make sure that you have arrived at this structure, that the functional groups and the ppm values match as well, okay. So if you look at that carbon, that's an alkene carbon, so most likely it is that carbon here, right? So let's label this carbon 1, 2, 3, and 4, okay. Carbon 1 is an alkene, carbon 2 is also an alkene. As we know, in C13 alkenes appear anywhere between 90 to 150, okay, 150. This one appears a little bit above 150 because this is not a simple alkene, it's an alkene that is next to an oxygen, all right. Therefore it is reasonable that it goes beyond the 150 range that you will expect for an alkene carbon. But that being said, you know which carbon is what. So this is carbon 1, okay, this is carbon 2, which is also an alkene but is farther away from the electronegative oxygen. Carbon 3 here is an aliphatic carbon, it is an sp3 carbon, therefore that is going to be the signal for the third carbon. And this carbon that you see here is attached to a double bond O, and usually when you have, as I mentioned in the C13 background information, that when you have a pure carbonyl, that is going to appear at 200 plus, okay, whereas here you have a lone pair from this ester oxygen that will make this carbon less electron deficient. Therefore that is this 180 that you're seeing here, which is carbon 4 that appears below 200, okay. So this structure matches all the peaks that you see in this NMR spectrum.